NCRT highlights we are discussing group 13 elements, oxidation state and trends in chemical reactivity. Due to small size of boron, the sum of its first three ionization enthalpies is very high. This prevents it to form plus 3 ions and forces it to form only covalent compounds. This will be a statement question. Boron forms only plus 3 ions and it can form ionic compounds. Statement 1. Statement 2. First three ionization enthalpies are very high. One is false, two is right. Okay, now these kind of statements will be given. So check this. Sum of first three ionization enthalpies of aluminum considerably decreases and therefore it can form Al plus 3. Aluminum is a highly electropositive metal. Inert pair effect. Gallium, indium, thallium, both plus 1 plus 3 are possible, but plus 1 stability down the group increases. In thallium, plus 1 is predominant because of inert pair effect. See, in this table, the most important point is E0 values you see. These are also asking nowadays. M plus 3 by M is positive for thallium. Can be asked, there is a possibility. But if that is the question, that is the case, it is not easy, man. Expected points only. These are electron deficient compounds because they have 6 electrons in the outermost shell after forming 3 bonds, and they can form readily dative bonds. Ammonia providing one lone pair of electrons. AlCl3 achieves stability by forming a dimer. Okay, in dimer you see it is tetrahedral. See, BCl3 is planar. When it is joining with ammonia, tetrahedral, and here it is already tetrahedral. The bridge chlorines bond length is more and normal bond length is less. Angles you see, outside angle is 118, inside angle is 79. And chlorine, aluminum angle is 101. So these are also asking nowadays. The bond angles in AlCl3 dimer. Okay, now Cl Al is greater, AlCl Al is next, AlCl Cl is next, inside. Like this they can be asking. But not acceptable. You can't do anything sometimes. Boron can form BOH4 minus type. Aluminum can form AlH2O taken 6 plus 3 type. That means it can expand its octet to 6 and sp3d2 hybridization is possible. In text questions also very important. You just look at this. Boron is unreactive in crystalline form. Very important. Aluminum forms a very thin oxide layer which protects regular reactions. Aluminum and gallium oxides are amphoteric. Indium and thallium are basic in nature. Boron trioxide is acidic. Boron does not react with acids and alkalis, even at moderate temperatures. Important. But aluminum dissolves in mineral acids and aqueous alkalis. Very interesting. Aluminum can react with acids as well as bases and release in both the cases hydrogen gas. Concentrated nitric acid renders aluminum passive by forming a protective oxide layer on the surface. Very important. Concentrated nitric acid makes aluminum passive. Aluminum with aqueous sodium hydroxide releases hydrogen gas. And here you see, here also 2 aluminum. In this case also it is 2 aluminum. It has gone as 2 aluminum. In both the cases 3H2 only. Okay, now 2 aluminum, 2 aluminum, 3H2, 3H2. So with excess of acid or base, the same amount of aluminum gives same volume of hydrogen. Note these kind of points. Towards halogen, they form MX3 type, EX3 type, except TLI3, remaining all are possible. So except means it is your question. White fumes appear around the bottle of anhydrous aluminum chloride. This is because anhydrous aluminum chloride is partially hydrolyzed with atmospheric moisture to liberate HCl gas. Moist HCl appears white in color. Very, very, very important. It's already in color, so it is not colored. Okay. Many other points are there. Important trends and anomalous properties will go in another video from here. Okay. Thank you.